Hi everyone and very warm welcome to your channel. In this video we are going to generate images from text with the help of this brand new model which is called as Emu3 from Bai. Before we do that, let's have a quick look at what exactly this model is. So this model, which has just been released is a new suite of state-of-the-art multimodal models, which has been trained solely with next token prediction. If you go to its Hugging Face card, you will see that in this diagram, and I will drop the link to it in video's description. So what is happening here is that by tokenizing images, text and videos into a discrete space with all the points, they have trained a single transformer from scratch on a mixture of multimodal sequences. Emu3 excels in both generation and perception. What it means is that not only you can generate images with the text, but also you can provide it your images and chat with them, and its perception quality is really amazing. In this video, we are just going to install it to generate images from text. In the subsequent videos, I will also be showing you the perception capabilities of these Emu3 models. Emu3 has outperformed several well-established task-specific models in both generation and perception tasks. It has surpassed flagship open models such as STXL, Lava 1.6 and OpenSora 1.2, while eliminating the need for diffusion or compositional architecture, which is a really groundbreaking stuff. Emu3 is also capable of generating high quality images following the text input by simply predicting the next vision token. The model naturally supports flexible resolutions and styles. So before I move forward, let me also thank the sponsors of this video, which are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page. It is resilient, it is reusable, and it structures output accordingly to the shape of your query. It is quite a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for. Okay, coming back to our this Emu3 model, another cool thing about this model is that its training data set is really of a very high quality, and all of the images which have been used in that data set are of very high fidelity. Okay, enough talk. Let's go to my terminal and get it installed. I'm running Ubuntu 22.04 and I have one GPU card of NVIDIA H100 with 80 GB of VRAM. I think you should be able to run this model easily on a 48 GB of VRAM, but I'm going to go with H100 courtesy Massed Compute, who are also sponsoring this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs, so do check them out. Let me clear the screen. First up, let's create a Conda environment. This is just a virtual environment where we will be installing and playing around with the model. Shouldn't take too long. Almost there, and that is there. Let's also install the GCC compiler and the NVIDIA CUDA. The reason why we are doing it, because this requires flash attention, and for flash attention you would need the GCC compiler. So let's wait for it to be completed. Okay, so the compiler is created. Next up, let's install some of the prerequisites like torch, torch vision, and transformers, and make sure that you install transformers latest version. Let's wait for it to get finished installing. All the prerequisites are done. Let's git clone the repo of Emu3 and then cd into it. That is done. Next up, let's install all the requirements from the root of this repo with the pip command, and this is going to take a minute or so, so let's wait for it to finish. All the requirements are now installed. Next, let's launch our Jupyter notebook so that we could download and play with this model in the browser environment. So let's wait for it to get launched. Our Jupyter notebook is launched. Let's import all the libraries which we have installed and then download the model, which is this Emu3 gen with its tokenizer. So let me run it. And the model has started downloading. There are 7 shards of it, and I believe the model size is somewhere around 35 gig. Let's wait for it to get downloaded. And the model is downloaded and also loaded onto our GPU. Let's try to do the inference. So I will be giving it a text prompt and then it is going to generate the image. We are giving it a positive prompt, that what should be in that image and what shouldn't be in that image in this negative prompt. And the prompt is a portrait of a 25-year-old young girl playing clarinet on stage. And then we are giving it some of the aspect ratio and then some of the parameters, generation config, and then we are converting the tokens into text, and this is where the next token prediction is happening. And then logits are being processed. Logits are simply the raw output from the model, and then model is generating the output, and then we are saving it here at the very end. So let me run it. Interestingly enough, it is running for the last 5 minutes just on this generation of the images, even on 80 GB of VRAM. Let's check out the VRAM usage, which is not exact science, but let's see. So it is just consuming around 23 GB of VRAM. So even I believe you can try it out on 24 GB of VRAM GPU card, but maybe I think 48 one would be better. This might give you out of memory error. But you see that even on this one where I'm running it on 80 GB of VRAM, it is running for a long time. Anyway, I will wait for it to come back and then we will see what it produces. It better produce something good if it is taking that much time. Okay, so it has come back eventually. It took around 10 minutes to generate it, and it has saved it on my local disk here in this folder. Let's see it. Oh wow, looks good. Yeah, this is bit off, but I think not bad at all. The quality is not bad. It is a stage, it is a clarinet looks good, and most of the stuff is really good stuff. Okay, that is awesome. Let's try out one more image generation. In the next prompt, I'm asking it that a majestic fire-breathing dragon perched atop a medieval castle surrounded by rolling hills and mystical mist. So let's wait for it to get generated. And it has finished generating. Let's check out the image. There you go. You know what? I think the image quality is sublime. It's really good. Look at the castle, look at the fire, look at this dragon, and then all the misty mountains around it. Follows the instructions to the hilt. And really good stuff, and attention to detail is also quite good. I think I'm quite impressed by the generation quality of this model. Takes a bit of a time though. Look, as I said, around 10 minutes or so. But the thing which it generates is really good quality. Let's try one last one. And in this last one, I'm asking it that a poignant wartime moment with a soldier reuniting with their loved one amidst ruins and chaos. So let's see what it generates. It could be a movie title too, by the way, or movie image. Okay, so it has generated the image. Let's check it out. Let me open it. Wow, there you go. But I think this is malformed, especially here the figure. The ruins and all that stuff is good. The soldier is good, but the other human figure is not really good, despite of the negative prompts. But other than that, I think I would say the graphics and the imagery is of a very high quality. Um, the last one was not good, but other than that, I think rest of it was really of very high standard. So that's it. Let me know what do you think. Um, Try it out, and if you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.